So LeetCode 897, increasing order search tree. So for this problem, it's an easy problem to train your in-order traversal on a tree, on a binary tree. For this problem, you're given the root of a binary search tree and you need to convert it to a sorted linked list, basically. Actually you need it to be a linked list made up of tree nodes. So you want to only use the right pointer of every tree node. But basically it's a linked list. Okay, so first thing, you want to lay down the framework for a in-order traversal. So the way you do an in-order traversal on a binary tree is you have a function in order and you call it on the root of your binary tree. And then you define your function as a base case, which is if your node is null, then you don't do anything, you stop your recursion, right? So if node is null, just stop the recursion. And then you have two recursion calls, which are just calling the same function on the node left pointer and on the node's right pointer, okay? And in between these two, that's where you do your business. So that's why the function is in order, because you call it on all of the values that are less than yourself, then you call it on yourself in between these two recursive calls, and then you call it on all of the values that are to your right, so all of the values that are greater than your current node's value. And now you just need to implement the thing that the problems wants us to do, which is converting everything to a linked list. And to do that, we just set up our head with a dummy node so that we do not have, the reason for which you use a dummy node instead of initializing head with null is so that at the end you just return head.right. So you discard your dummy node, and it makes for a really nice, concise code because you do not have to handle the case the first time where head is null. Like head is always a valid linked list node, and so you can always access its right pointer, and so you do not have the edge case where head is null. Okay, so that's why you use a dummy node. And now we also need a cursor that can actually move through the linked list, because at the end we need to return head.right. So we can't move head forward, so we need another pointer that can actually move forward in the linked list. And now all that's left is to append every node that we visit with our in-order traversal and append it to our list. And to do that, we just set the cursor right pointer to a new tree node with our current node's value. And then we need to move forward our cursor to the new tree node. Because if we don't do that, then the next call is just going to override the assignment that we just did. And we do not want that, because then we wouldn't have all of the values in the linked list. So since you want all of the values in the linked list, you don't want to override the assignment that you just did. And so you just move forward by one step in your linked list, like that, right? That's just how you move forward in a linked list. So that's it. I'll submit the solution to show you that it works. And the time complexity here is O of n, where n is the amount of nodes in your tree. And the space complexity is O of n because you need a list with all of the values. So you can't do anything better than that. So that's it from me today. Thank you for watching, and bye.